Hey everyone, this month is National Blood Donor Month, and so I wanted to dedicate some time to talking about the adaptations in blood from exercise. The most common one that people know about is blood sugar. So, as we exercise, blood sugar and blood sugar control improves. So, the way it improves is it helps facilitate the production of insulin and getting sugar into the muscles. And the and this is important in controlling specifically type 2 diabetes. I mean, it can help with type 1 diabetics, but they have to be very regimented with their insulin and making sure that they are always keeping track of their blood sugar. But with type 2 diabetic, it's usually secondary to some other cause like obesity or something along those lines. So one way to control the blood sugar in type 2 diabetic is to lose 10% of your body weight. That's a very good recommendation. Usually, if you do that, you can typically reverse the effects of type 2 diabetes in somebody that is overweight or obese. Um, Another adaptation that happens when you exercise is the effect on blood pressure. I'm not going to get too much into blood pressure. I really want to talk about that next month in February. That's National Heart Awareness Month. So for now, I'm just going to talk about basic what blood pressure is and how exercise affects it. So blood pressure is two numbers: your systolic, which is the top number. Usually, you want to be below 120 or below, and the diastolic, which is the bottom number, which you want to be below 90. Now, again, you can also be too low on both numbers, so you do want to be in a nice safe range for your blood pressure. The effects with exercise on blood pressure really happens immediately post exercise. So when you're on a cardio piece of equipment, let's say, your blood pressure won't increase too much, but immediately post exercise, your systolic pressure will come down about 6 to 8 millimeters of mercury, uh, and that's just based on a blood pressure cuff. But if you were to actually take your blood pressure before and after, you would see a decrease in systolic pressure, the top number, which is very good news for people that have high blood pressure. Another indicator in blood work that you can find to see how well trained somebody is lactate threshold. Lactate threshold is just a point where your body is producing more lactate than the liver can remove. So what does that actually mean? So if you were doing a VO2 max test, let's say you're trying to go for your max oxygen consumption or submax test, that lactate threshold is again where you're getting fatigued and the body is using glycolysis, anaerobic glycolysis, which is another energy system separate from the aerobic system. It's a much shorter, quicker system, and I have more information on that in another post, and I'll try to get the blog down below that you can find. But mainly, what you want to know with the lactate threshold is, the more trained you are, the longer it takes to get to that lactate threshold, and the less trained you are, the quicker you get there. So you want to be able to delay that lactate threshold as long as possible. Aerobic and anaerobic training can help with that. Another adaptation in blood is stroke volume, and this is getting a little more into the heart function of things, which we'll talk more about next month. But stroke volume is how much blood the blood pumps gets pumped out of the heart uh, in between beats. So when you're at rest in between beats, you're filling up the atrias. When you are when your heart is beating and contracting, that the ventricles are releasing. So with the stroke volume, you're able to release more blood than you would if you were untrained. And the stroke volume is really affected by body size. So the bigger you are, the higher your stroke volume is going to be naturally. but you can improve it through cardio training. And one of the other adaptations to it is, the heart's a muscle, so that left ventricle that pumps out to the rest of the body, that's going to get stronger. The walls of that ventricle are going to get stronger to help facilitate a stronger stroke volume. Another adaptation for the body is, and through the bloodstream, is cardiac output. And cardiac output equals heart rate times stroke volume. So as you can see, when you get more trained, that left ventricle is stronger, pumping more blood out. So stroke volume will increase, but because you're doing cardiovascular exercise, your heart rate might decrease. So your cardiac output actually stays the same. And believe it or not, um, cardiac output can actually decrease as you get trained, just slightly. But usually it stays pretty constant no matter what you do because of the give and take between the heart rate and the stroke volume. Also, uh, that decreases due to the body delivering oxygen better to itself. And finally, since we're talking about blood, we got to talk about blood flow. So, blood flow actually can increase with training. This is due to increased capillarization, which means your body makes more capillaries to the trained muscles, better recruitment of those capillaries, and more blood flow uh, from inactive organs. So what your body does is it shunts blood away from organs that's not using. So when you start exercising, the brain says, "Oh, okay, I'm not digesting right now. Let me get rid of blood flow from the stomach and the intestines and get that out to the muscles because they're working right now, and I need to facilitate oxygen delivery to the muscles." So this is achieved through increased blood volume, and the way to increase blood volume is to increase the plasma volume, which is just the fluid in the veins and arteries, and this is done through protein in the bloodstream going into interstitial fluid, which is the fluid in between organs, and that osmosis pulls the water from high concentration to low concentration. So you're going to pull the water to the bloodstream, and there's also going to affect protein synthesis, which helps the body reabsorb water and sodium from the kidneys, and that's controlled through hormones. Uh, so that blood volume, that plasma volume, is also going to affect the red blood cells. So when you exercise, you actually create more red blood cells. The crazy thing though is that even though you increase red blood cells, that is actually overshadowed by the fact that you have more fluid, more plasma volume. So that plasma volume actually reduces your red blood count to the plasma, which is called your hematocrit. So one of the reasons for that, or one of the theories behind that, is that increased plasma volume and reduced hematocrit, so less red blood cells per volume, is going to allow more red blood cells into the capillaries, which is going to be more easily distributed to the working muscles. So the capillaries are very thin, very small. They're the smallest blood vessel in the body, and they go right into the muscles to get that red blood cell to deliver that oxygen. So it's very important that you do have that increase in plasma volume and that decrease in hematocrit, and that way you can get better facilitation of the red blood cells to the muscles. So that's everything about uh, and that's a quick overview of how blood is affected by exercise. For more information, you can go to my website and follow up with some articles. I'll post some down below for suggestions. And if you have any questions, please feel free to reach out to me. I'm on Instagram, Twitter, and YouTube at Just a Guy Fitness